Hello and welcome. I'm a senior AI architect, and in this tutorial, we're going to do a deep dive into a fundamental design pattern for building intelligent systems, routing.
So, here's how we're going to break it down today. First, we'll cover what routing actually is, then we'll look at the flow, how it works visually. After that, we'll dig into the core logic, talk about the business case, why you should care, and finally, we'll wrap up with the key takeaways.
Okay, let's dive right into it. So what is routing? At its heart, you can think of it as making a really smart decision, right at the very start of a process. It's all about directing AI traffic.
The main idea here is it's simple, but it's also incredibly powerful. See, instead of having one giant monolithic model that tries to do absolutely everything, we use a much smaller, lightweight router to send the incoming query to the best specialist for that job. Simple as that.
Now, you might be asking, how is that routing decision actually made? Well, there are a few ways. You can use simple rule-based routing. Basic if-else statements that look for keywords. It's super fast. Or you could get a bit more sophisticated with embedding-based routing, which looks at the semantic meaning of the query to find the best match. And then there's ML model-based routing, where you actually train a small, specialized model just to handle this one task.
Okay, let's move on and actually visualize how this works in practice. I want you to think of the router as a fork in the road for AI queries. It's that first critical decision point.
So this really breaks down the process beautifully. A query comes in from a user. The router then takes a look and analyzes its intent. Is this a math problem? Is it a coding question? Or is it just general chit-chat? And then, based on that analysis, it sends the query off to the most appropriate downstream agent. Super clean.
Okay, so how does the router actually perform this analysis? Let's get into the nitty-gritty and look at the underlying logic, especially for the simplest and, honestly, the most common approach you'll see.
So, at its simplest, what does this logic even look like? Well, the great thing is, it doesn't have to be complicated. In many cases, it's just a really straightforward conditional check. So, this table really lays out the logic for us. Essentially, the router is just checking the classification that's been assigned to the query. If it's been tagged as math, then boom, it returns the math agent. If it's tagged as code, it calls the coding agent. And for anything else, it just defaults to the general chat agent. It's a really simple but super effective control mechanism.
All right, so let's connect all this back to the real world. Why does this actually matter for the projects you're working on? Well, the answer really comes down to two things: efficiency and, maybe more importantly, cost.
And it really boils down to this. Not all queries are created equal, right? Some tasks are really simple, but others need some serious analytical horsepower. And using your most powerful, most expensive AI model for every single query, well, that's just not efficient. It's a waste of money.
This is where you're going to see the biggest impact. By routing those simple queries to a faster, cheaper model, say a Gemini Flash or a GPT 3.5, and then saving your more powerful, more expensive model for the really complex stuff, you can drastically cut your operational costs. And you do it without sacrificing quality on the tasks that actually need that power. Okay, so to wrap everything up, let's just quickly go over the most important points to remember from this tutorial.
So the really crucial point here is that routing is your main tool for creating efficient, cost-effective, and specialized agent systems. It lets you direct traffic, it optimizes your resources, and it allows you to build much more adaptive and intelligent applications overall.
And that kind of leaves us with a final thought to chew on. We've seen how a central router can manage a team of agents, but the next evolution is dynamic, multi-agent systems where the agents can actually start routing themselves, modifying the team's structure to solve a problem. It's a pretty cool idea. Anyway, thank you for joining this explainer.